Resources Corporation, Southern California Edison, Kern Schools Federal Credit Union, Panama Buena Vista Union School District, and the San Luis Obispo County Office of Education, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
We are live today at the Boys and Girls Club, Stockdale location, and we're here to...
Well, good afternoon and welcome to Do the Math. I'm Michael.
And I'm Chuck. Our phone tutors are here today until 5:30. If you have any questions about your math, you can call us here in Bakersfield at 636-4357. You can call toll-free from the outlying areas such as San Luis Obispo at 1-866-636-6284. You can email us questions if you want at dothemath@kern.org. You can watch a show online at dothemathonline.net. And we're on social media. You can look for us on Facebook and Instagram and Twitter and on YouTube.
Speaking of the out-of-town phone calls,
yes.
I spoke with Doc Bernstein's associate, Kat, today over in San Luis Obispo County. And we just wanted to remind everybody that if you phone in from San Luis Obispo County and we do one of your math problems live on air, you will automatically be getting ice cream courtesy of Doc Bernstein's Ice Cream Lab.
That's a great deal.
So, and I know we're going over there in November to do some filming.
All right.
And we've got a little something extra special coming up in October. But in the meantime, you can still get some free ice cream for the students over there.
Nice.
Other things going on, Kern County Fair opens this week. And every student that phones in today and tomorrow will be receiving a ticket to go to the Kern County Fair simply by doing your math problem on TV. And as if that wasn't enough,
more.
Your name is automatically thrown into a drawing for a family 4-pack to go see the Bakersfield Condors, and we do that every single day.
Yes.
So that's a little something to look forward to as well.
Good.
Well, we'll be heading out to the Boys and Girls Club in a little while. We have a very special guest in studio, but first let's take a look at today's Math in the News. Do you have any hobbies? Maybe when you were younger you had a hobby and it's not so much anymore. You have started a new hobby or something you've had for a long time. Any hobbies?
Yeah, I used to do macrame when I was in school.
Okay.
Knots, and never took it. My wife crochets and.
Okay, well that's something actually it has to do with exactly with what we're talking about today. You know, I remember when we were young and there was I forget the guy. It was Rosie, football player, Rosie Greer maybe?
Rosie Greer, right?
Did some knitting?
Yep.
Or was it, you know, he's a famous football player and
That's
people
right.
were like, oh, he knits or whatever, you know, and there was a stigmatism stereotype of football players and
Yes.
things. But I found this article about knitting and crocheting and the mathematical designs behind them.
Yes.
So here I've got a couple of photos of some different designs that have mathematical designs behind them. So we're not going to talk about all of them, but they're pretty fascinating when you look at them.
Yeah.
These are actual physical objects that people have made following a mathematical formula. So that struck me. I mean, these things are just phenomenal.
Yeah, some of them look like they're just computer generated, but that's
Somebody's
something actually
making
made.
these.
Right.
And so this one right here. Now, it says, our greatest achievement is an Afghan called Counting Pain. Okay? And the first row, so we'll look up here, the first row going across, so that way the students will understand the difference between a row and a column, okay, is representing the numbers 1 through 10. So this solid blue represents 1. The color at the top, okay, so now the yellow represents a 2, the red represents 3, and so on the way they go. The way you look at it is if the numbers down below are divisible, they can go into the other numbers, okay? So we can see this goes all the way across to 10. here's 11. None of these numbers can go into 11 besides 1, which is why it is solid blue.
Right.
12, okay, we'll take one with less colors. Here's 14, okay? And we can see that there is some yellow in there because 2 will go into 14.
Got it.
There's blue because 1 obviously goes into 14, and we see there's white. Well, if we look at the white, this is the number 7, and we see that 7 goes into 14. So that's why these colors are on here in this order.
So that means that every square up there has to have some blue in it,
Right,
because every number is divisible by 1.
Exactly.
I see.
Which is why there's a lot of blue, and I mean, some of them are thin, but there's some blue in all of them, okay? So I found that pretty fascinating, you know, that somebody could come up with how to do that and then knit, crochet that, make that.
Right.
So there's another thing called folding dragons, okay, paper dragons. You can fold some paper, okay?
Okay.
So what you do is, here, go ahead and take a strip of paper. I've got a strip of paper. So you're going to fold it in half. Okay, you want to fold it the same way every time. So if you're folding from left to right, that's what you're going to continue doing.
Okay.
All right, so you fold it again. And then you can fold it again. And what you do is you just put some creases in there. And then you unfold it. And I know the cameras won't be able to see it the way it is now, so I'll go ahead and tilt it this way for the cameras, and maybe camera 3 or something can get on there. But you can see how you have the folds, and you have a section and you have a corner where the crease is, okay? So you count the position of the fold. This is how you determine if it is an odd fold or an even fold, okay? So you count the position of fold from the left of the sequence. Keep dividing by 2 until an odd number is reached. And then you add 1, divide by 2. If it's an even fold, it's going to have an I fold. And if it's odd, it's going to be an O fold. So an example.
Okay.
Okay. Position 20. So there's 20 sections of this. Okay. 20 divided by 2 is 10. 10 divided by 2 is 5. So you keep dividing by 2 right here until an odd number is reached. So we get to an odd number, 5. The next rule says add 1. So 5 plus 1 is 6. Divide that number by 2. We divide it by 2.
Because now it's even, right?
So we have a 3. 3 is odd, so the fold is an O fold, an odd fold. Okay?
Got it.
Now, what you can do with these is the number of folds, the sections and corners. All right? So the section will always be one more than the number of corners. So if we look, so this is a section.
Section.
So you have 1, 2, 3, 4, 5, 6, 7, 8 sections.
Got it.
Now the corners are right here. So we've got 1, 2, 3, 4, 5, 6, 7.
Right.
So you can make a little table like that because the number of sections will always be one more than the number of corners.
Right.
And you can see a pattern with that. And just this exercise is something that you can do with young kids to start having them develop a sense of seeing patterns.
Right.
And they can physically make these things, and they can try, let me just fold it twice and see what happens.
And work with odd and even numbers, and work
all
with
sorts of
and
things
work
that you
with
can
your
do with these.
operations of division and addition, and that's great.
Right. So, I mean, and all of this stuff comes with these knitting and crocheting is all part of it. And these paper dragons, one of these things is there are these designs that they put into these things. So let's see, I'm going to put this on here and we'll see if we can focus in on that right there. And we can see a dragon, this is on a cushion, right? So that is a paper dragon into that cushion and being able to know exactly, it's not just random what they're doing.
Right.
But I just found this all fascinating, and
Because most people think they just follow a picture and do the knitting or the or the stitching, but it's actually a mathematical pattern that gives them that.
there's a lot more to it.
Yeah.
Right. Well, in studio with us right now, we have a very special guest. This is Allie. How are you today?
Good.
And why don't you let everybody know where you go to school and what grade you're in?
Stockdale Elementary,
And what grade are you in?
4th.
4th grade. And do you do a lot of knitting or crocheting yet?
No.
Did you find that pretty cool, fascinating with that knitting and crocheting though? I thought that was pretty fascinating when I found something like that. Here's what we're going to do. Take this strip of paper. We're going to have you make a paper dragon right now. All right, so go ahead and fold it once. You can fold it however many times you like. So you can fold it once, twice, or 3 times. All right, you let me know when you're all through. You all through?
Yeah.
Okay, so before you unfold it, go ahead like that and put a crease in it. Once again, really, so go right across that paper on both sides of it. All right, and then what you can do is we'll open it up, and now the key is, were you paying attention while you were waiting off on the side? Or just a little bit?
A little bit.
Just a little bit. All right, so here's what you're going to do. You're going to be able to tell all your family and friends to go on our YouTube channel, and they can check out about the paper dragon and how to do that thing, and about the sections in the corners, and then you can look at it and remember how to do that. Sound good?
Yeah.
All right, now we're going to make you do some math homework today. Are you ready for that?
Yeah.
Okay, but before we make you do that, we're going to first of all head back out to the Boys and Girls Club with Mary Lou.
We are live today at the Boys and Girls Club at the Stockdale location, and I am here today with Vincent. Hi, Vincent.
Hello.
How you doing?
Good.
And what school do you go to?
I go to Stockdale Elementary.
And what grade are you in?
I'm in 6th grade.
Ah, have you been there since kindergarten?
No, I've been there since 3rd grade.
Ah, what's your favorite thing about the school?
PE.
Ah, yes, that was my favorite too. Why?
Because it keeps me active, and it gives us time to play with our friends and hop around when we do laps around the school.
Very cool. Are you a fast runner?
Yeah.
Good job. Good job. All right, so we got a math problem today, right?
Yep.
So our directions are find the prime factorization. That's a pretty big word. Vincent, can you tell us what prime factorization means?
Prime factorization means you're going to break down the number from whatever number you have until you can get it to the smallest form, until you can't break it down anymore, and then you put it from least to greatest across with multiplication.
So what we're really doing is finding all the
Prime factors.
exactly of the number. Very good. Okay, get started. Tell us how to do this. Our number is 90. So show us how you're going to solve this.
So what you're going to do is you're going to put a 2 right here, bring this down, and you're going to find out what multiplies into that. So 45 would go into that. So you're going to try to break down 45 into 5 times 9. And then you're going to break down the 9 to 3 times 3.
Okay, can I ask you a question? How come you didn't break down the 2?
Because it's the smallest form and you can't break it down anymore.
And 2 is actually the only even number that is
Not prime.
Well, it is prime, right?
Yeah.
And what about 5? How come you didn't break down 5?
Because you can't break down 5 because it's not an even number.
Very good, and it's also prime, right? And what does prime mean?
Prime means it's not an even number and you can't break it down anymore to multiply something by something to get 5.
There's only one set, right? That equals 5, which is 5 times 1. Very good. So obviously 3 is a prime number as well.
Yes.
Okay, well we're not done, right?
Not quite.
Okay, what do we need to do next?
So you're going to put the numbers from least to greatest. So you're going to go 2 times 3 times 3 times 5. And there's your answer.
So if we multiplied then, Vincent, all those together, what does that equal?
90.
Is that a good way to double check to make sure you have the right answer?
Yes.
Okay, so we broke it down, we found the prime factorization, but let's look at this problem. This problem, we already are given the prime factorization, so now we need to know what it equals. Okay, solve that for us.
So we all know 2 times 2 equals 4. So you're going to multiply 4 times 7, 28. And then you're going to multiply by 13. You get 24. 8, bring a 0. 8
and just 2, right? And now we have
So
2?
then we have to add it.
Okay.
And you get 4. 364.
So therefore, our prime numbers of 2 times 2 times 7 times 13 is 364. I'm going to show you one more quick step before we leave, okay? It's called the exponent form. Okay? Now, I'm going to put this into exponent form. We only have 1, 2.
Yeah.
Okay? How many 3's do we have?
2.
So we can say 2 times 3 squared. Do you know what 3 squared is?
Yes.
What is it?
It's to the
It's 3 times.
3 times 2.
Well, it's actually 3 times 3 because it's saying what is 3 times 3? I have 2 3's, and that's where I got 3 squared from. Times
5.
5, and that's called exponent form. On this one, how many 2's do we have?
2.
Okay, so write that for me. 2 to the what power?
2 to the power of 2.
Very good. Times.
Times 4.
Well, times 7 times,
Times 13.
and there you go. You just changed that to an exponent form. Awesome job, Vincent. Thank you very much. And back to you, Mike, at the studio.
All right, thanks for that, Mary Lou. It's always lovely to see you surrounded with about 70 kids having to do all of those math problems. 636-4357 is the phone number. We do have phone tutors available on Tuesdays and Wednesdays between 3:30 and 5:30. As a reminder, if you do your problem live on air between 4 and 5, your name is automatically entered into a drawing, and that drawing every single day is for a family 4-pack to go see the Bakersfield Condors. Outlying areas of Kern County as well as San Luis Obispo County, that phone number is toll free at 1-866-636-6284. In studio with us once again, we have Allie, a 4th grade student, and Allie is all ready to do one of her math homework problems. Are you ready?
Yeah.
All right, head on over to the board. I'll read it, and then you guys can go ahead and start working on it. So the problem says there are 27 campers. So is there anything you want to write down yet? 27 would be good. All right. This is 9 times as many as the number of counselors. So that 27 is 9 times the number of counselors. I don't want to put that part of the I on there for you. So 27 is 9 times, is that what you're trying to write?
9 times. So 9
The
times
number of
something,
counselors,
right?
right.
So I think, did they put let's just do that, right? We don't know what that number is, right?
So the question is, how many counselors do they have? So that's what you need to figure out. So you explain to Chuck how you would like to solve that problem.
Well, I'd multiply 27 times 9.
Well, see, it's saying that 27 is, now you started to write is, didn't you? But I noticed when you're doing this problem, what do you write down instead of the is? You know it's symbol?
Equal.
Equal, so that equal is going to be right here, isn't it? So we know that 27 is 9 times the number of counselors, isn't it? So here's the question, what number do you have to multiply times 9 to get 27? And so you know that, right? You know
Yeah.
that 9 times 3 is 27. So what was the question? It was
How many counselors are
how
there?
many counselors are? Oh, look at that. It just disappeared. What happened to it? And so the answer to this question, how many counselors are there? And your answer was 3, isn't it? So it looks like the answer is 3.
Good. Well, you know what?
So
That
that's
one didn't take so long, so let me have you do another one, all right? Here we go. Let's do number 10 here.
Okay?
It says 5 times as many as 6 is 30. So what you need to do is write an equation is what they want you to do here. So I'll say it one more time. 5 times as many as 6
So that's going to be 6, right?
is 30.
And that is the same as
Equal.
the equal sign. So put your equal sign. And there's your equation, isn't it?
All right.
And that's it.
Well, that was too simple. Let's give you another one. Let's see.
One more.
We'll mix it up a little bit. 72 is 8 times as many as 9. You need it one more time?
Yeah.
All right. 72 is 8 times as many as 9.
So it goes down first. And then what's the is?
Equal.
So I'll say it again. 72 is 8 times as many as 9.
And there's our answer.
All right, nicely done. Come on back over here, Allie. We'll give you a break for just a moment. 636-4357 is the phone number. I do believe we have another phone call waiting, and is that correct in the back? We've got another phone call waiting? All right, so here we go. We've got Aiden from Old River. Aiden, how are you today?
I'm good.
As soon as you're ready, let's hear the math problem you're working on.
Okay. So, my math problem is 3 parentheses 2k plus 4 parentheses positive 6 parentheses negative 5k parentheses negative 1 but parentheses negative 8 parentheses.
Okay, so let's make sure we got that right. 3 and then parentheses 2k plus 4 inside the parentheses, right?
Yes.
Plus 6 and then inside parentheses just negative 5k.
Yes.
And then minus 1 times parentheses negative 8. So
Yes.
can you see the problem? Does that look like what you have?
Yes.
Okay. So what we have to do is what? What's it say? Simplify?
Can you repeat that?
Yeah, so what are the directions on your problem?
We have to do 3 times 2k.
Right, so we're gonna do this, but you're not solving anything, right? You're just gonna simplify the expression?
Yes.
Yeah, and so there's 2 parts to simplifying it, right? The
Yes.
first part that you just said was, let's get rid of those parentheses, right?
Yes.
So what are we gonna do with that 3?
We're going to multiply it by the 2k.
Right, because- Go ahead.
And we're going to multiply it by the positive 4.
Right, because we know that that 3 in front of the parentheses means multiplication, don't we?
Yes.
Even though there's no multiplication sign there, you could put one there, and we know that the 3 in front of the parentheses means to multiply, and we got to multiply everything inside the parentheses, right? So what do you get when we do that?
I get 6k and positive 12.
Plus 12, okay. So we don't need any parentheses, we got rid of the multiplication and got 2 terms, didn't we? Now
Yes.
over here you only have 1 term in the parentheses, don't you?
Yes.
So when you multiply 6 times negative 5k, what do you get?
Negative 3k.
Now let me ask you, do you write this as plus a negative 30k or do you write it as minus 30k?
Oh, positive.
Well, you
Positive
went,
30k.
yeah, but you went 6 times negative 5, right?
Yes.
So positive 6 times negative 5 is negative 30, right?
Yes.
So my question is, do you write this as plus a negative 30 or minus 30k? You have a choice.
Negative 30k.
Right, so we're going to write it as minus 30k. Depending on your teacher and sometimes your book, sometimes they'll write it as a plus a negative 30k, right? So we're just going to write it as minus 30k. Now we'll do the last one. What's negative 1 times negative 8?
Negative 8.
Except what's negative times negative?
Positive.
Positive. So when you multiply them, again, here's multiplication here and multiplication here. You know that a negative times a negative is a positive 8, right? So step 1 was get rid of all the parentheses, wasn't it?
Yes.
And you did that. Now what's next?
Combine the like terms.
Right, so what are your like terms here?
They are 6 and k and 30 and k.
Yeah,
and
so we have
positive 12 and negative 8.
So let's
They're
underline
positive.
them the same, right? So you have 6k and minus 30k, right?
Yes.
And you have a plus 12. Oh, let me ask you this. Why are 6k and 30k like terms?
Because they both have a k.
They both have a variable, the same variable, don't they? And 12, the 12 and the 8, I'll underline those 2 times. Why are those like terms?
Because they don't have any numbers, or not any numbers, any letters at all.
Right, so they're just numbers, no letters, and so those are like terms. Like terms means they're alike, they're the same, aren't they? So what is 6k minus 30k?
6k minus 30k? That would be 24k?
Yeah, so you know it's going to be 24 because one of them's positive and one of them's negative, right?
Yes.
So what's 6 minus 30? You said it's 24. Is it positive 24 or negative 24?
Negative.
Yeah, because we have a big negative number here, don't we?
Yes.
So it's more negative than it is positive, so this is going to be a negative 24, and we have to keep the k, don't we?
Yes.
And then our other like terms are 12 and 8. What's 12 plus 8? Well, that's pretty easy.
20.
That's just plus 20. Now you got to be careful. Some people want to do one more step and combine these two terms. We can't add these two together, can we?
No, because they don't have, they're not like terms.
They're not like terms. One's got a variable, a k, and one doesn't. And so these are unlike terms, and they don't combine. And so that looks like your answer, and we're all done. Thanks for the call.
All right, you still online with us, Aiden, quickly there?
Yes.
All right, well, you know what? Because you called in with that problem, I can see kind of where you went wrong with that negative 8 with that positive. But because it was such a good problem, we're going to send you to the Kern County Fair. So congratulations on that. 636-4357 is the phone number. We do have phone tutors available until 5:30. And I do believe we were set up for a break, but I'm just going to check in the back because I know another call went back there. Are we ready to do the call, or are we just going to go to the break? All right, here's what we're going to do. We're going to go to the break, and we'll get to the phone calls right after this. Today we're at scenic Fraser Park, home of El Cajon School, and today we're here to... All right, today we're at El Cajon School, and right now I've got Emmett, a 6th grader. How are you today?
Good.
You doing ready?
Yeah.
All right, let's go. Grab a marker. I'm going to read off some scores, and I'm sure these are pretty comparable to the scores you get on your math tests. You're pretty good at math?
Yeah.
All right, here we go. Let's go 98. So go ahead and put 98 up there. And we're going to add these numbers. Okay, so you can write them however you want to, horizontally or vertically, to do this. 97, 92, 85, and 93. So those are the scores on 5 tests. What we'd like to know is what was your average for all of the tests?
Okay.
So as you do this, go ahead and explain to me what you're doing.
5 plus 3 is 8, plus 2 is 10. Carry the 1. 9 plus 1 is 10, plus the 8 is 18. 18 plus 9, or 8 plus 9 is 17, plus 10 is 27.
Good. An easier way of doing it.
And then 8 plus 7 would be 15. Carry the 1. 18. 9 plus 9 is 18. Plus the 1 is 19.
Okay.
195 plus 270. 5 plus 0 is 5. 9 plus 7 is 16. 2 plus 2 is 4.
Okay. So the total is 465 out of all of these. And what I like is how you broke this up into chunks. Instead of adding a lot of numbers, you just broke it up to make it a little easier. So now we have 465, but we want to know the average of your scores. So that, like, let's say they put it on the report card. They want to know what you average. What's the next step?
465 divided by 5.
Right. And how do you know that you divided by 5?
By how many numbers there were to add.
Right. So 465 divided by 5.
5 can't go into 4, so 5 goes into 46 9 times, which would be 45. 9 times 5 is 45. Subtract would be 15. You have to bring down the 5.
Okay.
And then 5 goes into 15 3 times, which would be 15. Subtract that, 0, so there is no remainder. 93 is my average.
So is that your real average in math, do you think, right now? 93? Or is it higher?
I think it's higher.
It's higher? All right. Well, you know what, Emmett? Nice job. Well done.
Thank you.
Well, this afternoon we're at El Cajon School, and I've got 6th grader Danelia with us. Danelia, we're going to work on a problem. You ready? Let's take a look at what we've got up here already. I'm going to read you a little bit about it, but some of the information we need is already up here. Have you ever been to the Lincoln Memorial in Washington, D.C.?
No.
Fabulous if you get an opportunity, all right? But that's what we're going to talk about today. A statue of Abraham Lincoln in the Lincoln Memorial has a height of 60 feet. So that statue of Abraham Lincoln is 60 feet. They built a scale model of it. The model is only 4 inches, okay? We want to know how many feet of the statue is equal to 1 inch. So if 4 inches is equal to 60 feet, we want to know how many feet is represented by 1 inch, okay? So do you have an idea how you would like to solve this problem?
Division?
Division, okay? So let's go ahead, and there's a bunch of different ways you could set this up and do it, or you could simply divide it to get to 1, all right? Because we want to go 1 inch, all right? So what would you divide right now?
60 divided by 4.
Okay, so go ahead and grab a marker and go ahead and start doing that. All right, and explain to me what you're doing as you go ahead and go through the process.
Okay. Well, 4 goes into 6.
You'll only go in one time, right? Because 4 times 2 is 8, and that's too much, right? So it'll only go in there once, okay?
Which is 4, right?
Right.
So you subtract 6 minus 4 is 2.
Mm-hmm. And now what do you do?
Then you bring down the 0.
Perfect.
4 goes into 20. Five times.
Mm-hmm.
Then that's 20.
Right.
Then you subtract, which is 0, and remainder is 0.
Okay, so what is the answer?
15.
15 what? So think about the question again. So it says we have a 60-foot statue, and the scale model is 4 inches. The model is 4 inches. All right, and we want to know what 1 inch represents in feet. So 1 inch is how many feet represented?
15 feet?
15 feet. So over here on the side, just go ahead and put 15 feet. And that is the scale. 1 inch is representative of 15 feet. So the scale would be 1 inch to 15 feet. Danelia, nicely done. Oh, once again, we'd like to thank everybody at El Cajon School. We had a wonderful time when we were up there. Allie, have you ever been to El Cajon?
No.
Frazier Park?
No.
I bet maybe you have. Have you ever been south of Bakersfield? Have you ever gone to LA? Ask your mom. Yeah? Mm-hmm. So when you go up the mountain, that's Frazier Park up there. And when you go up there, when you're getting close to the top, if you look off to your left, you're going to see a school, and that's where we went. So you can go, hey, I know those kids over there. I've seen them on TV. And they're going to say, hey, I know her. I've seen her on TV too, right? Okay. We're going to get you back to work in a couple minutes. Are you ready?
Yeah.
All right. Take a breather right now. Right now, we're going to go back to the phones for a student from Buena Vista. And Evan, how are you today?
I'm good.
Good. Are you ready to do your math problem?
Yes, I am.
All right. I think we have the correct one up on the board. So take a look at the board and see if that's the math problem you're working on or if it's a different one.
They are not at the board right now.
So can you see the TV or the monitor?
Yes.
So maybe now you can
and
with it.
My
Okay.
problem is not up.
Is this your problem?
What?
Is that the math problem you're working on?
It is, yes.
Good.
Good.
All right.
Okay, so let's, Evan, let's go ahead and work through this problem, okay? You have 2k in parentheses 4 minus 3k, right? Minus, in parentheses, negative 3 plus 2k. All right, so what do we have to do? What are the directions for this problem?
So we'd start with the first set of parentheses
Sure, and
by
we're,
doing 2k times 4.
because we know that this is multiplication, right? So
Yes.
we know that this is the distributive property. It means multiply everything inside the parentheses by 2k. What do you get? 2k times 4, what is that?
That is 8k.
8k. Then 2k times negative 3k.
Would be negative 6k.
Negative
Squared.
6, and it's k times k, isn't it, right? So k to the second power, or k squared, right? Now you notice here we only have one thing inside the parentheses, so what is minus a negative 3?
That would be negative, we put a 1 there.
So that's
And then it'd
negative,
be negative 1 times negative 3, which would be positive 3.
positive 3. So negative 1 times negative 3, positive 3. And the 2k we don't do anything to, do we? No parentheses, no multiplication. All right, now what's the last thing we have to do once we get rid of the parentheses?
We take the plus 2k and move it down.
Move it down. Where are we going to move it?
We're going to move it with the rest of the numbers that we got. We're going to move it with the 8k and the negative 6k squared.
Okay, so we have that 2k and the 8k. So we're going to move those together. Is that what you're saying?
What I'm saying is we'll just move down the 2k.
Move it over to here?
Yeah.
So let's just write this as 8k plus 2k like this,
Yes.
minus 6k squared plus 3. So we just use another property. This is the commutative property, which means we can move things around. And what's 8k plus 2k?
8k plus 2k is 10k.
So 10k. Do we have any other like terms with the minus 6k squared?
No, because we cannot add the
10 added.
6k
This
squared.
has got, and do we have any like terms with the 3?
Nope.
No. Now, the only other thing that you might see is you have a 10k minus 6k squared plus 3, but most of the time they're going to want you to put these in order. So the other thing we're going to do is move these around. I'll put the minus 6k squared first, then the positive 10k, and then plus 3. And just put them in order, okay?
Okay.
And that should be your answer.
Well, nicely done right there, Evan. And because that was such a wonderful problem, we're going to also send you to the Kern County Fair. Evan, are you still online?
Yes, I am.
All right. Have you been to the Kern County Fair before?
Yes, I have.
Is
I
there
have in the past.
is there a favorite part of the fair that you're looking forward to going to?
I definitely like the pig races.
Okay. Well, I think
There you
everybody
go.
does. All right. Well, congratulations. Thanks for phoning in this afternoon. Do remember we have phone tutors available until 5:30 at 636-4357. Have you been to the fair before?
Yes.
What do you like about the fair?
Everything.
You like everything about it? If you had to pick one thing, if they said you can either go to the rides, to the animals, to the food,
Animals.
the animals? All right. Well, you know what? You're going to the Kern County Fair too because you're here doing work all day. Speaking of doing work, we're going to go back out to the Stockdale site for the Boys and Girls Club and head on out and see who Mary Lou is working with.
Thanks, Mike. We're back here live at the Boys and Girls Club, the Stockdale location. I have another friend with me, Samantha. How are you doing today?
Good.
What school do you go to?
Ronald Reagan Elementary.
And what grade are you in?
4th.
Okay, we were talking a little bit. And what is your favorite subject?
Math.
Yay! Okay, so multiplication, yes? Yes, a lot of students have trouble with multiplication. So let's work on some strategies to help us with multiplication today. Okay, so we know that, I know that you know 2 times 6. What is 2 times 6?
12.
Good, write 12 up there for me, Samantha. Okay, But what is this really saying? This is saying that we have two groups of 6. So multiplication is really repeated.
Addition.
Very good. So what this is really saying is 6 plus 6. We could double check. Is that 12?
Yes.
All right. Okay, so let's move on to something a little bit more, because once we get past 5s, that's where students kind of have trouble, past the 5s. So let's look at another, let's go to 7. Let's say 3 times 7. Now, again, is this saying we have 3 groups of 7? So let's write out 7 plus 7 plus 7, because we have 3 groups of 7. So now, Samantha, we need to add these together, don't we? So a lot of times, if you can't remember what it is, memorize it, we can change it to an addition problem to help us. So what is 7 plus 7?
14.
Okay, let's do a 14 down there. And then we're going to bring down the plus 7. So bring down a plus and a 7. So what's 14 plus 7?
21.
Yes. There you go. So what is 3 times 7?
21.
Awesome. Got another problem for you. What's one problem you really have difficulties with?
9 times 8.
9 times 8. Okay, let's write that up here. Write 9 times 8. So again, this is saying I have 9 groups of 8. So that means we need to do 9 8s, don't we? And that's a lot. Let's go ahead and do 9 8s. So do an 8 and a plus, and let's... We got plenty of room. Keep going. 1. There's 4. There's the 5th one. You're getting smaller and smaller there. I think we have one more. 1, 2, 3, 4, 5, 6, 7, 8, and 9. That's an awful lot of 8s, isn't it? Yeah, that's a hard one to do. You got a lot of addition, right, on this one. We could add them all up. We know that 8 plus 8 is what?
16.
We know another 8 plus 8 is?
16.
We know another 8 plus 8 is?
16.
Another 8 plus 8 is?
16.
Plus 8, right? Again, there's a lot of numbers. I'm going to help you out here. 16 plus 16 is 32.
2.
Right, 32 there. So 16 plus 16 again is?
32.
And then we just have a plus? 8. Okay, in the center here, I want you to do 32 for me. Right, 32. Nice. And underneath, write another 32. And then put 8 underneath the 2. Guess what I'm going to have you do with all these numbers?
Add them.
Yes, please. There you go. Guess what 9 times 8 is?
72.
72. That was a lot of work, wasn't it? Okay, so I'm going to take your chalk from you. I'm going to show you another trick real quick. All right? Okay, put your back to the camera. Turn around. Put your hands up. Okay, so starting here, this is 1, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? What I want you to do is, I want you to put down your 8th finger, which is right here. This is your 8th finger. Put it down.
This one?
Yep. How many, hold your hands up. How many numbers, how many fingers do we have before this one? We have 1, 2, 3, 4, 5,
6, 7.
7. And how many fingers after?
2.
What does 7 and 2 make?
14.
No, what does 7 and 2 make?
72.
Ready? Let's do another one. We're going to say 9 times 4. So we're going to put down the 4th finger. Put down your 4th finger. How many fingers before do you have?
3.
How many fingers after?
6.
36. Want one more? Okay, ready? 9 times 2. Up, this way. 9 times 2. So you're going to put down the second finger, which you have 1 here. And how many do you have following?
8, so 18.
Woohoo! Good job. All right, Mike, back to you.
A keen little trick
Yes,
right there.
it
You know
is.
what? I mean, there's all sorts of ways that you can learn multiplication. 636-4357 is the number. We're going to go back to the phones right now. A student from Castle Elementary. And Christopher, how are you this afternoon?
Good.
And what grade are you in?
I'm in the 6th grade.
As soon as you're ready, let's hear the math problem that you're working on.
4, this is a ratio, it's 4 to 1.
4, now do they write it in words 4 to 1? Like this, 4 to 1? Or how do they write the ratio?
It says 4 to 1, 4 boys to 1 girl.
Okay. Boys to girls. Got it. Okay. Now what?
Then it says that what would the total of the team be?
What other information do you have?
It says the coated soccer team has 4 times as many boys on it as it has girls.
Yes.
We say the ratio of the number of the boys to the number of girls on the team is 4 to 1. We read this is as 4 to 1.
Okay.
And do they give you any other numbers?
No, just those.
So,
So
now
you need to draw a diagram. Is that what you need to do?
Yeah, tape diagram.
That's what we need to know. Okay.
Oh, okay. So what is it? What is it? What is the diagram? What do they want you to write?
A line, a box with 4 lines in it, and another box with no lines.
So like a ratio, something like this, like with boxes, like this.
Yes,
Probably, yeah.
So there's 4 to 1, like this.
yes,
Okay. And so we have a ratio of 4 boys to 1 girl. Is that right?
yes.
Now, do they give you anything else that they want you to put in those boxes?
And
Is there
what would the total of players be?
Okay. So how many, do they tell you how many girls or how many boys?
4 boys and 1 girl.
Okay, there's 4 boys to every girl. Did they tell you how many girls are on the team?
Yeah, 1 girl.
Oh, there's only 1 girl on the team?
Yes,
Okay, so there's 1 girl on the team, so that's 1, isn't it?
yes,
Okay, so each one of these boxes is going to be 1, isn't there?
yes.
Okay, so how many boys are on the team?
4.
4. So if this represents the entire team, how many people are on the team?
6.
Well, let's see, we got 1, 2, 3, 4 boys and
1 girl.
1 girl. So how many boxes do we have?
4.
5, don't we? We've got
Yes.
5 boxes altogether, right? 4 of
Yes.
them are boys, 1 are girl. So they want the total number on the team. How many people are on the team? 5 is your total. Okay, so we take that ratio, wrote it as a diagram with the boxes, and then just counted up all of the boxes to make our total. And that should be your answer. Okay?
Thank you.
Okay.
All
thanks for calling.
right, easy enough problem. Christopher, thanks for calling in. Because you called in today, we're going to send you to the Kern County Fair as well. Do you eat any of the food at the fair?
Yes.
Do you have a favorite thing at the food at the fair that you eat that you like? Oh, I gotta have this when I go to the fair.
I don't know.
Well, I'm sure you're going to find something this year, right?
Yes.
I think they have these things that are like pizza things inside, like a meatball. I don't know. Go check it out when you're there, all right? But first, I need you to get back to work. So back over to the board, young lady.
Okay, let's go.
All right, here we go. One other problem that you have here says Sean and Leah are playing a computer game. Do we really need to know any of that?
No.
No, not really. Sean scored 72,491 points.
Just the point. There you go. Try to do it.
72,491. Leah scored 19,326 points more than Sean. So she scored that many more than Sean.
So more than this. So If you want 19,326 more than 72,491, what do you have to do with those two numbers?
Add.
Add them. So let's go ahead and add them up. And let's see what we get. Okay, so how many points total?
91,817.
Okay, and that should be your answer.
All right, nicely done. You know what? Since you did that one so quickly, we're going to do one more for you, all right?
Okay.
So this is one, I saw that I made you do this problem already, but we're going to have you do it now to show some other students in case they're just learning how to do this, all right? So the first number on the left-hand side,
So let's start over here.
you're going to write 547,098. Yep, 098. And then you're going to put a big circle in between to the right of it.
Yeah, big circle. There
And
you
now the next number is 574,000.
go. No, wait, let's see, 574.
Yep,
Yeah,
so
you got it.
574,000.
Let's get rid of the 0, 2. No, get rid of the 0, 2.
Because she's going 500,000.
Yeah, let's go. You get rid of both of the zeros.
So here, it might be easier if I just tell you what numbers to write.
Yeah, there we go.
So 574, comma, 908, 908. Now, in there, the directions say put a symbol in there to make that statement true. So what are you going to put in there? And what does that mean? Because there's some students going, I don't know what that means. What is that? You put two lines, you put an arrow in there. What does that mean?
Greater than,
So explain how you know that's greater than.
because there's a 7 there and a 4 there.
Okay, but they both have 5s.
Yes.
So so one has a 7 and one has a 4, but they both have 7 and 4s. You see how all the numbers are the same?
Yes,
So
but
how do you know that you're correct?
the 7 is before the 4,
Okay, so on that one, the 7's before the 4?
and the 7 is after on the
So-
other one.
Okay, so what place value are you looking at to make you positive that this is the right answer?
10,000s.
You know what? You are on it. That is exactly what I was looking for. Get back over here, young lady. I thought I was going to be able to throw you off a little bit right there and trick you and see if you were just going to fall for whatever number, but you already knew that was the 10,000s place, right?
Yeah.
All right. You want to see some more kids work at the Boys and Girls Club?
Okay.
All right, so do I. So we're going to send back out there with Mary Lou.
We are live today at the Boys and Girls Club at the Stockdale location, and yet another friend today, Lacey. Hello.
Hi.
And what school do you go to, Lacey?
Leo B. Hart.
And what grade are you in?
5th.
5th grade. Okay, so I've been asking what your favorite thing at school is.
Math.
Yay! Why?
Because I love multiplying and doing math.
Well, we have a really big multiplication problem, don't we? Seems like multiplication is the name of, the day, right? Okay, so we have 55,687 multiplied by 94,592. You ready?
Yeah.
Okay, so nice and loud, talk us through this. How are we going to solve this?
First, we're going to do 7 times 2, which is 14. And then you put the 1
I'll get the 1 for you. There you go.
And then you do 2 times 8, which is 16, plus 1 is 17. So you put 7 and 1 up there. And then you do 2 times 6, which is 12, plus 1 would equal 13. And then you do 2 times 5, which is 10, plus 1 would equal 11. And then you do 2 times 5 again, it would equal 10, plus 1 more would be 11 again.
Okay, so we got the first number done. I'm going to take these away so we don't get confused next time. And what do we need to do when we start the next row?
We add a 0.
Okay, because that 0 really represents, this is in the tens place value, right?
And it represents the 1.
Okay, go for it.
Okay, so 9 times 7, it would equal 63. And then 9 times 8 would equal 72, plus 6 would equal 78. And then 9 times 6 would equal 54 plus 7 equals 61.
Wow, good job. 61? Yep.
And then 9 times 5 would equal 45 plus 6 would equal 51. And then next you do 9 times 5 again, 45 plus 1 equals 46.
Good job. And I love the way you are lining up all your place values. That is really important because if you don't, then you lose where you're at. Okay, what are we doing here?
We're adding one more zero.
One more or two more? 2 zeros.
2.
All right. The 2 zeros, again, because the 5 now is in the hundreds place
And
value.
then those 2 represent the ones and the tens.
Okay, we're going to go fast here.
And 5 times 7 is 35. And then 5 times 8 is 40 plus 3 equals 43. Then 5 times 6 would equal 30 plus 4 would equal 34.
Okay.
And then 5 times 5 is 25 plus 3 is 28. And then 5 times 5 again is 25 and plus 2 would equal 27.
Okay. I'm going to quickly do the last. We're right here on the 4s, right?
Yep.
I'm going to do those quickly for us so we could get these added together because you're doing an amazing job. So help with me real quick. 4 times 7 is?
28.
28. Carry our 2. 4 times 8 is?
32.
34, right?
Yeah.
Carry the 3. 4 times 6 is?
24
4.
plus 3 is 27.
7. 4 times 5?
22.
And lastly, 4 times 5 again is?
22.
22 again. How many zeros this time?
4.
All right, here we go. 9 times 7.
63.
9 times 8.
78.
Good job. 9 times 6.
61.
Okay. 45. Is that 51?
Yep.
And again, is that 50? Okay, ready? We're going to quickly add this together.
So
4. Put another 0 here for 10. We have, let's see, 13, 14, 15, 16, 17. We have 11, 12, 13, 14. We have 8, 9, 10, 11, 12, 13, 14 again. Let's see, there is 15, and 8 is 23, 29, 30, 31. There's 10, 14, 15, put a 5. There's 4, 5, and 6. Put a 2 and a 5, and oh my goodness. Woo, give me 5. All right, Lacey, that was great. All right, Mike, back to you.
All right, nicely done. Do remember we have phone tutors available until 5:30. And right now we're going to give away that family 4-pack to the Bakersfield Condors. And Allie, go ahead, reach in there and find out who's going to the Condors.
Samantha Reagan.
Samantha from Reagan, a 4th grade student. So congratulations to Samantha. And until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, California Resources Corporation, Southern California Edison, Kern Schools Federal Credit Union, Panama Buena Vista Union School District, and the San Luis Obispo County Office of Education, with additional production assistance provided by the supporters of education in Kern County and throughout the state of California. Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, California Resources Corporation, Southern California Edison, Kern Schools Federal Credit Union, Panama Buena Vista Union School District, and the San Luis Obispo County Office of Education, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
We are live today at 100th anniversary of the Great Kern County Fair, and we're here
Well, good afternoon and welcome to Do the Math. I'm Michael.
And I'm Chuck. We've got our phone tutors here to help you with your math this afternoon. Give us a call here in Bakersfield at 636-4357. San Luis Obispo and the outlying areas, you can call toll free. It's 1-866-636-6284. You can email us questions at dothemath@kern.org. You can watch the show live online at dothemathonline.net. And you can look for us on social media. We're on Facebook and Instagram, Twitter, and YouTube.
All right, well, you know what? Speaking of out of town,
Yes.
students that call in from San Luis Obispo County, when we do your math problem on air, you will be eligible. You're automatically going to win Doc Bernstein's Ice Cream Lab ice cream. So all you have to do is call in and go, hey, I've got this math problem I need work on. We'll help you out with it. And because you used the service and got a little bit of help, we'll give you a little bit of ice cream.
Great deal.
So I bet you Mary Lou will be getting some ice cream out of the Kern County Fair. So we'll check in with those guys in a little bit. We have a special guest in studio, but before we do all of that, let's first take a look at today's Math in the News. All right, so one of the things that we do in class is in the GATE program, we do a lot of art and artists, study about them and the different styles of art and things like that. One of the things the students do is they're drawing people, bodies, heads, and things like that. Faces. Also. So I found an article that was talking about ideal lengths and the ideal eyelash length. I didn't even know there was such a thing until I saw the article, but it fascinated me. It's supposed to be 1/3 the width of the eye. Okay, because sometimes you see people with eyelashes and they're more than 1/3 the width of the eye. They're probably the width of the eye.
The width of the eye, right.
And then some people have very, very, very short eyelashes. Yes. You know, it's like, do you have eyelashes? But I guess there's an ideal length. So using that length, I was looking, all right, the ideal sizes for kids when they're using a scale to draw a full-size person. So the head should be 1/8 of the total size of the body that you're drawing.
Okay.
So if you are drawing somebody that is 6 feet, they're going to be 10 inches. How big should the head be? So if the whole thing is going to be 10 inches to represent a 6-foot person, how big should the head be? Because some kids could draw a really large head on that person, and it wouldn't be proportionally correct. Some draw really small.
Yes.
But here's how you can figure it out. So you would take 1/8 of the 10 inches, which is 1/8 times 10, and then you come out to 1.25 inches.
So the body, the picture would be 10 inches for the entire body, and the head would be 1.25 inches.
Correct. And that's exactly how you kind of go about using that. But I figured that was pretty cool. Eyelash length, and we'll put that into some art.
And I know that the golden ratio figures into the proportions of the parts of the body also.
Right.
Yes.
Yeah, there's a lot of things that we could do with that. But we will be going out to the Kern County Fair in a little while. But first we have Serena with us. And how are you today?
Good.
Why don't you introduce, well, we already know you're Serena, but let everybody know where you go to school and what grade you're in.
I go to Stockdale Elementary and I'm in 5th grade.
How's 5th grade going?
Good.
It's all right? No problems?
No.
All right. What is the most difficult thing then about 5th grade?
All of the extra things that we do, like chorus and instruments.
So you're involved in a lot of things now.
Yes.
So is time management kind of something you're working on this year?
Yes.
Now, I understand because when I said, did you bring any math homework with you today? What did you say?
No, we don't have math homework.
Ah, there we go. That struck me as odd. We don't have math homework in 5th grade, okay? Now, it could be because you're doing a lot of work just in class and they want to see only what you're doing in class. But since you don't have any math homework, we're going to make you do other kids' math homework today.
Okay.
Okay, does that sound fine?
Yes.
All right, so that's what we're going to do. 636-4357, we do have phone tutors available, but I believe we're going to go out to the Kern County Fair and check in with Mary Lou.
We are live back here at the Great Kern County Fair, and I am with Michelle, who is with us from Science for Kern. How you doing today?
I'm great.
And we are here at the Chevron Pavilion, right?
Yes, we are.
And can you tell us a little bit what you do with Science for Kern?
Well, Science for Kern is a lending library. We have 8 different STEM units available for teachers to check out. We focus on 4th and 5th grade all over Kern County. Magnets, so I have the Magnets unit out here today. Magnets is just one of the 8 units that we have available. Teachers can go to my website, scienceforkern.org, and reserve one of the 8 units. And then I deliver the unit. I come with the unit. I do a demo lesson, get the teachers started on teaching the lesson, and they can keep it for 15 school days. And then I come back after the 15 days and pick it up, and then they can check out another unit.
Now, you say 8 different, so they're different all. What?
Yes.
Can you give us an example of what one unit might be?
I have magnets, there's electricity, I have scientific method, I have matter and erosion, and the list goes on and on.
Okay, well, we have some examples. We have the Anna and Antonia back over here, and they're doing some experiments. Can you tell us what they're working with?
Sure. So, this is, as I mentioned, this is our magnets unit, and one of the lessons has to do with polarity, positive and negative. So girls, I want you to take this, and I want you to try to float the magnets so none of them are touching. And take all 4 off. There you go, take the magnets apart. And then try to, they can't even touch the base. See if you can stack them on there without touching. This activity is called floating magnets. Let it go. Pull it up, modify in some way. So you can get it, there you go. Now put another one on and make it fuller. Excellent, I think you get the hang of it. And this is an example of an activity that teachers can use to teach positive and negative charges on a magnet. Attract and repel is taught through this lesson. Excellent, way to go.
I love this even for teaching integers because the kids have to understand that when you have a positive and negative, that well, it's not going to come together. This is excellent.
Right, exactly. Now over here, we have a plate of just regular office paper clips. Take this magnet, and I want you to pick up one paper clip and one with your hand, and let's stick it on there. And then hold it up. See how many more you can fish for out of the plate. That's great. Okay, let's try that again. One on there, and then see how many you can pull up one at a time, making a chain of paper clips. There you go. Oh, almost.
There you go.
Yeah, way to go. All right. So take them off. Now, does it matter where on the magnet you try to form your chain? From the tray, try the other side. Will it work the same? Excellent. Now let's try the electromagnet. Pick up the red horseshoe and hold it over the steel shapes. What happens?
It doesn't.
Nothing, right? Absolutely nothing happens. Now, do you think that you could take the horseshoe magnet, the 2 alligator clamps, and our power source and hook them all up and have that power? Pick up
some still shapes. There we go. It's crazy little, those are tough.
There you go.
Got it? There you go. Hold it over the tray. Can you get them all? So what do you think must be happening in order for all of those to stick together? Because you'll notice they're not all touching the metal part. And how about here? What do you notice about what you've formed there? Why does it pick up steel shapes now and it didn't do it before? Right, so we call this electricity, and electricity flows in a circular pattern. Right now, pick any of the 4 clamps and let them go. Pull a clamp off and see what happens.
There you go. Pull one off. Just pull that off real quick. Just take it off.
There you go.
There you go. And it releases. All right. This is great examples of what you have. Now you are sponsored through
Chevron. Chevron is our sponsor.
Great. Well, thank you so much.
Thank you. Thanks for coming out.
Mike, back to you in the studio.
See all that science going on out there, as well as a little bit of math. And nice to see Michelle from Science for Kern, new to that position, and get her working.
Good.
That's exactly what we need to do. We have phone tutors available until 5:30. 636-4357 is that phone number. Toll free, the number's on the screen periodically throughout the program. Right now, we'll go to our first phone call. Caitlin, how are you today? Hello, Caitlin.
Hello.
And you're a 6th grade student at Reagan, correct?
Yep.
All right. As soon as you're ready, we're going to have you let us know what your problem is, and we have 2 tutors for you to work with today. As soon as you're ready, Caitlin, let's hear it.
All right. The problem I am working on is -4, open parentheses, a plus 3, close parentheses.
I'm sorry, a plus 3?
Yeah, the letter A.
The letter A plus 3, is that what I heard?
How does that look, Caitlin?
Yeah.
And then
-8.
minus 8?
Yeah,
think
-8.
I think A, the letter A is an apple, or 8, the number?
A.
A is an apple.
The letter A.
All right, so the directions you have for this problem are what? Simplify? Is that what it asks you to do?
Yes, simplify.
All right, so do you know the 2 steps that we have to do to simplify this?
Yeah. Multiply the parentheses.
Okay, so let's get rid of the parentheses. So Serena, do you know what we're going to do? Do you know the distributive property by any chance?
Yes.
Yes.
So we're going to multiply that -4 times both of those. So have you worked with variables, Serena?
No.
So we're going to multiply -4 times a, which very nicely is just -4a, okay?
Yeah.
But then we're going to multiply -4 times 3. What's -4 times 3?
-12.
So go ahead and write down the -12.
Negative
And then write the -8.
minus.
All right.
Okay, so your first step is, Caitlin, is to remove the parentheses, right?
Right.
But we're not done yet, are we? What else do we have to do?
We have to bring the A down.
Okay, so we have the -4a and the -12 and the -8, right?
Yes.
And now what do we have to do?
We have to combine a like term.
So you notice, Serena, that one of the terms has an a, but these 2 are just numbers, aren't they?
Yes.
So go ahead and add those together. What's a -12 minus 8? Do you know what that is?
We haven't worked with negatives yet. We haven't
Well,
worked
what's
with
12 plus 8?
12 plus 8 would be 12.
Wait, what?
So, Caitlin, what's 12 plus 8?
It's 20.
12 plus 8? You can't add that, can you?
Yeah, well, we have the -4a, right? But we have a
yeah.
-12 and a -8, or a -12 minus 8. And these are just numbers, so what's 12 plus 8?
-5a?
Well, except they're both negative, aren't they? So we're going to add them together.
12 plus 8 is...
Do you want me to write it
If you add them together, what do you get 12 plus 8?
20.
20, so put down a 20. And since they're both negative, it's going to be a minus 20, isn't it? So put a
Negative 20?
So it looks like, to combine terms, we only have two like terms, the two numbers, right? And the minus 4a stays the same. So it looks like, Caitlin, our answer is going to
Right.
be negative 4a minus 20. And since these are unlike terms, we can't combine those, can we? Some people try to add these together and get like a negative 24a, and that we can't do that because there's no a on that term. So there's our answer, okay? Thanks for the call.
All right, nicely done right there, Caitlin, because you did get in with that problem right there. We're going to send you to the Kern County Fair. So congratulations on that. Do remember we have phone tutors available until 5:30 at 636-4357. Toll free, that number is 1-866-636-6284. Don't forget, you can also email any of your problems because we have email available, and that email address is dothemath@kern.org. Sometimes students email that in, and because they don't have time to watch the program, specifically between 4 and 5 o'clock live. So you can send that in previously,
Right.
or maybe tonight so we can get to it tomorrow. But it's always good to email it so that we can look at it on Tuesday or Wednesday.
Otherwise, you got to wait a whole week.
Right.
And yeah.
That's no fun to wait for your problem to be done that whole time. All right, we're going to go back. Another student from Reagan. Dixie, how are you today?
I'm good.
And are you working on the same type of a problem, doing expressions?
What?
Are you simplifying expressions or something else?
I'm simplifying.
Excellent. Back to the work.
Okay, let's try another one.
As soon as you're ready, Dixie, let's hear it.
3 in parentheses 2k plus 4 plus out of parentheses is plus 6. In parentheses is minus 5k. Out of parentheses is negative 1, and then in parentheses is negative 8.
Okay, so let me make sure I got all of what you just said. You said 3 and then inside parentheses 2k plus 4,
Yes.
and then plus 6 parentheses negative 5k, right?
Yes.
Nothing else is in there but the negative 5k?
Negative 5k is the only thing.
And then minus 1 times parentheses negative 8, right?
Yes.
Okay. So we know that in simplifying expressions, we got to get rid of those parentheses, right?
Yes.
And we have to combine terms. So let's get rid of all of those parentheses. So here's the distributive property again, right? So what do we get? What's 3 times 2k?
6k.
Well, we know 3 times 2 is 6. Go ahead and write down the 6k. And then we're going to do 3 times 4, right?
Yes, that's 12.
So plus 12. Now you notice we use the distributive property because we had 2 terms inside with parentheses with the plus sign, but here we only have 1 term. So to get rid of these parentheses, all we have to do is 1 multiplication. So we're going to take 6 times negative 5k, right? Well, what is that? So what's 6 times 5?
30.
30s, so that's going to be a 30. And we have the k still, so put the k. And is it positive or negative?
Negative.
So because 6 times negative 5 is negative 30, we're going to subtract that 30k. Some people will write it as plus a negative 30, but we're just going to go minus 30k, right? Is that what you guys do?
Yes.
Dixie? Okay. And finally, what's negative 1 times negative 8?
Positive 8.
Yeah, negative times negative. This is what you'll get next year, Serena, is positive. That's just going to be 8, and it's going to be a plus. All right, so very nicely, in one step, we got rid of all of the parentheses, didn't we? But we're not done because we have to combine like terms. So what are the like terms?
6k and 30k.
So I'll underline those the same way, right? A 6k and a minus 30k. So what is 6 minus 30? So now we have to decide, what do you do when you have 1 positive and 1 negative? Remember the rule?
Minus the,
You subtract, you minus, right? So what's 30 minus 6?
30 minus 6 is 24.
So right, let's go ahead and write 24.
Right here.
Yeah, right there is fine. And those terms had a k, so put a k there. And now let's see. You said 30 minus 6 is 24, but we have 6 minus 30, don't we?
Yes.
So what's 6 minus 30?
Negative 24?
Negative 24. The bigger number is negative, so go ahead and put a negative sign in front of that 24. Okay?
Okay.
And then the other two like terms are just the numbers, aren't they? The 12 and the 8. And we just did a problem like this. What's 12 plus 8?
20.
12 plus 8 is 20.
So we'll put plus 20 because they're both positive. So it's real nice to do everything and keep everything in order and do it right below so we can keep track of everything, make sure we get rid of all the parentheses. And then some people like to underline the like terms so that they don't miss any of them and they don't do anything extra. And have we gotten everything we needed to?
Yep.
We have two unlike terms, and looks like we're done. Thanks for the call.
Nicely done, Dixie. Hey, if you're still on the line, guess what? We're going to be sending you as well to the Kern County Fair, so congratulations on that. You know, I like just handing out tickets. All the kids let them go to the fair for free like that. Serena, are you kind of getting the hang of this a little bit?
Yes.
I know you're brand new to simplifying expressions probably, right?
Yeah.
But after a few more, I'm sure you'll start getting the hang of it a little bit more. All right, we're going to go back to the phones. A lot of kids
one
calling
more.
in
All
today
right.
from Buena Vista.
Keep
Evan,
going.
how are you this afternoon?
I'm good.
And you are a 6th grade student, correct?
Yes.
And I know that you have called here before, and you are the same Evan that we were able to send out to CSUB last week with the Fab Lab, correct?
Yes, I am.
How was that experience? Can you tell us just a little bit about it briefly?
Yes. It was an amazing experience where we got to use laser printers, 3D printers to make a keychain. It was an awesome experience.
Good. Well, you know what? I'm glad that you had a fun time out there. And if you want to find out more at home about the Fab Lab out at CSUB, just go on CSUB's website, type in Fab Lab. You'll be able to find all that information. And as they were saying last week, anybody can sign up to go out there, make whatever you think of.
Yeah, the equipment they had out there that people could use and the materials, that really was amazing.
All right. Evan, as soon as you're ready, let's hear the math problem that you're working on.
Okay. The math problem is 4 start parentheses, d plus 3 end parentheses, minus start parentheses, d minus 1 end parentheses equals 64.
Oh, good. We've moved
now
on
we
from
have an
expressions.
equation. So let me ask you, make sure, can you see the equation? I want to make sure we have it right? 4 times parentheses c plus 3 minus parentheses c minus 1 equals 64. Got that right?
Yes, that's correct.
Okay, so now let's go ahead and do what we've done, right? So let's use the distribute property. What do we get? 4 times c.
Would be
4 times c is 4c.
4c, so put that up. And 4 times 3.
Plus 12.
Plus 12. Now, we don't have anything to multiply by here, do we? We have the parentheses, but there's no number in front, so it's just minus that. So do they have you put a number there?
Yes, we put
What?
the number 1.
So if you think of that negative, how many of these do we have? You have one of those sets of parentheses, don't you? So let's multiply by negative 1. Well, multiplying by 1 is easy, isn't it?
yeah.
1 times c is just c, but we have to take that negative with us. So what are we going to have?
Negative c.
Minus c. And negative 1 times negative 1. What's negative times negative?
Positive.
Positive. So that's going to be a plus 1. So the effect was, by multiplying by a negative 1, you just change the signs of both of those terms, the letter and the number inside the parentheses. Now we still have that equals 64, but we're not going to do anything with that. That's on the other side of the equation, right? We're going to work on one side at a time.
Yes.
Because what are we going to do with the left side of that equation before we try to solve it?
We're
What else?
going to combine like terms.
Now, we're still combining like terms. So we're doing exactly what we did on the other problems that we had before we solved the equation. So let's see, what are our like terms? 4c minus c. How many c's is that?
2.
That is
You have
plus
4,
3c.
and you take away 1, you have 3c. So write down 3c. And very easily, 12 plus 1 is
13.
13. So plus 13.
Yep.
And that all equals, that 64 is still over there, right?
Yes.
All right, so what we've done is just simplified that expression. This is what you've been doing before, isn't it?
Yes.
So now we're going to solve that equation. In other words, solve the equation means find the value of c, right? What number do I have to put in here for c so that this equation, this sentence is true? So what do you have to do to solve an equation, Evan?
We need to get rid of the plus 13.
Yeah, we need to get rid of the plus 13 and we need to get rid of the 3, right? So the c. So how do you get rid of that plus 13? How do you get rid of addition?
By subtracting.
So we're going to subtract. So right underneath that. Now, do you do it on the same line or do you do it below?
Below.
Below, okay. So right here, under that 13, let's subtract 13. We've got this balance scale. Evan, did you guys talk about a balance scale with equations?
I don't think so.
No, now we're going to do, no, leave that here. So on one side, we did a minus 13, but whatever we do to one side, we have to do to the other, don't we? To keep this equation balanced. So on the other side of the equation, that's why we have this line. Over here, we're going to do a minus 13 also.
Yes.
And let's just do that subtraction. I'll do the easy part. 13 minus 13 is 0, isn't it?
Yes.
What's 64 minus 13?
That would be
51.
So go ahead and put that down. So on one side of the equation, you've got 51. On the other side of the equation we have 3c, right?
Yes.
We haven't solved for c yet, though, have we?
No.
We want to know,
No.
what does c equal? So how do we get rid of that 3?
By dividing by.
Now, why dividing? Why are you dividing?
Because since there's a 3 next to a variable, it always needs multiplication, and we need to do the opposite of the
So
function.
we know that 3c means 3 times c, don't we?
Yes.
Even though there wasn't a multiplication sign there, we know it means multiplication. So that means to undo that multiplication, you said divide. So let's go ahead and divide. So go ahead and put a 3 underneath both of those. We're going to divide by setting up a fraction. 3 divided by 3 and 51. Again, whatever you do to one side, you have to do to the other side, don't you? Again,
Yeah.
I'm going to do the easy part. 3 divided by 3, 1, right? So here was 0 because we were subtracting and they canceled out. Here when I divide, 3 divided by 3 is 1. And 1c is just c, isn't it? I don't need the
Yeah.
1 in front, do I? And what's, let me put an equal sign there, what's 51 divided by 3?
51 divided by 3 is 17.
17. So 51 divided, so our answer right here is 17. So it looks like the answer to your equation is 17. Is it?
Yes.
How do you know? Well, we didn't make any mistakes, did we?
No.
But what are you supposed to do with your answer to check your answer to an equation?
Put the number that we got next to the variable to check our work.
Yeah, so I'm going to take that 17 that I had here, and I'm going to go all the way back to the original equation and check our answer. Let's check it. What's 17 plus 3?
17 plus 3 is 20.
20, and I'm going to multiply that by 4. And what's 17 minus 1?
17 minus 1 is 16.
16, and I'm going to subtract that. We said negative 1 times 16. So what's 4 times 20?
80.
80 minus 16?
74.
I got to borrow.
64.
It's 64, and so our answer checks, doesn't it? Right? So once you get your answer down at the bottom, we go back to the first equation, check to see if it works. Okay? Thanks a lot for the call, Evan.
Nicely done right there, Evan. Do remember we have phone tutors available until 5:30. I think we were on a little run of expressions, and we may start seeing some equations
All right.
coming through now. Hey, you know what? We'll be back out at the Kern County Fair right after this. Today we're at scenic Fraser Park, home of El Cajon School, and today we're here to... Well, this afternoon we're at El Cajon School, and with me right now I've got Caitlin, a 7th grade student. And how long have you been at this school?
3 years.
3 years? Is your 5th year? Everything going well?
Yeah.
One more year?
Yeah.
All right, well, let's go ahead and work on a math problem right now. All right, so I'm going to read some information, and then you can mark however you need to. Okay? So, there was a student that rounded 10.68494 to the nearest hundredth. So why don't we go ahead, and how would you round this to the nearest hundredth?
You look at this number, and if it's 5 or over, you round this one up.
Okay, so you're looking at the 4 first, right?
Yeah.
And why do you look at the 4?
Because it's the next number after the hundredth.
Right, because this is tenths, hundredths. So you're correct in looking at the hundredths and the number after it. And as you said, what is key with this? What do you do with that number?
You round it down because it's under 5.
Right, so what would this number round off to be? So go ahead and write the new number over there. Well, you said this number is going to...
Yeah, this one's smaller, so it makes...
So that's
oh,
gonna
wait,
stay.
no,
There
I'm
you
just
go.
kidding. I'm just kidding.
Well, that's all right. The kid, I'm an old man. You can do that a little bit, all right? But so the 4 is going to keep this the same.
Yeah.
If it was a 6,
It would make this become 9.
right? Okay. So then you take the same number and round it to the nearest whole number. So what would that turn into? So you want a whole number now. And what were you looking at? How do you know this is 11?
That number, and it's over 5, so it makes this number change to the next one up.
Okay. And since we have 2 numbers after the decimal here, well, why don't you go ahead and put a decimal and put 2 numbers after that, which would going to be what?
Zeros.
Zeros, because that doesn't change the value. It's still 11.
Yeah.
We would like to know the positive difference between these 2 numbers. And all that means is what is the difference between the 2 numbers? All right? And what is the difference between those 2 numbers? How would you do that?
You would subtract 10.68 minus 11.
Well, are you going to go 10.6?
11 minus 10.68.
There you go. So go ahead and do that for us. So what is the difference between the 2 numbers?
0.32.
0.32. And how would you read that instead of saying 0.32? How else could you say that?
3200.
Perfect, 32 hundredths. But what I'd like you to do now is another step. Are you ready? I would like you to represent that as a fraction in simplest form. So explain what you did. So you took 0.32, 32 hundredths, you turned it into a fraction, which is correct, 32 hundredths. And then what did you do?
I divided that by a number that, the least number that can go into both of them, or the most number that can go into both of them, and then got 8.
And how do you know, like, is 825 the simplest form?
Yeah, because no number can go into both of them.
Right, so no number can go into 8 and 25, so you know you're in simplest form.
Yeah.
Caitlin? Perfect.
Thank you.
Well, once again, we're at El Cajon, and right now I've got 8th grade student Emily. Are you well? You feeling all right? You're not nervous?
I am.
But everything's going to be fine. I promise.
Okay.
Now, you were saying that you have no idea what the problem is, because all the other kids, they were like, oh, I kind of get an idea what's going to happen.
Yeah.
And we'll see you're in 8th grade, so I'm not going to give you any clue.
Okay.
All right? So here we go. I'll read the problem to you. You write down anything that you feel is going to be important. What is the positive difference between 2 to the 5th and 5 squared? So, up once again. So, the first number I gave you was 2 to the 5th. So, how would you write that? 2 to the 5th power. Good. And the other number was 5 squared, 5 to the 2nd power. And we want to know what is the difference between those 2 numbers. So first of all, there are some students that are going to be wondering how you're writing numbers like this and what those mean. So is there anything you can explain about the 2 and the 5?
Yeah, so it means that you do 2 5 times.
Okay, so this would be the base number, the 2,
Yeah.
and then you have an exponent of 5, which means you're going to multiply 2 5 times. So go ahead and write that out so students can see what that actually looks like. Right. Because sometimes a student would look at this and go 2 to the 5th and say 10. Right? Do you see how they
Yeah.
might do that? But it's not going to be 10. So go ahead and show what that would be.
So 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32.
Okay. And then if you would be so kind as to write out 5 squared
Which
the same
is
way.
5 times 5,
Okay.
which is 25.
And the question is, what is the positive difference between those two numbers? So what would you do now?
Subtract 2
And
numbers.
what would you get?
5 minus 2, 12. 7.
That's it, right?
Yeah.
Okay, now the reason I had you do this problem is because sometimes a lot of students will go, well, the 5 looks bigger, so it's going to be a bigger number, but it actually became smaller, right, because of the exponent. All right? So 2 to the 5th is actually larger than 5 squared, and the difference between them is 7. Easy enough problem, right? All right, Emily, nicely done. And once again, a big thanks to all of the students and the staff up at El Cajon Middle School. We had a great time up there, and the kids were all fabulous to work with, so we hope that you guys are all able to view your little bit right there, because we let the principal know when your part is coming on so that you can watch that. Do remember we have phone tutors available until 5:30 on Tuesdays and Wednesdays. If you'd like us to come to your school, all you have to do is give us a call. The phone numbers are on the screen. Just say, hey, we'd like you guys to come on out, and we'll get some information and see if we can make it work. Right now, we're going to head back out to the Kern County Fair with Mary Lou.
We are back live at the Chevron Pavilion at the Great Kern County Fair. I'm here with Danielle and Maria.
Hello.
And they are with the Mix It Up Kids Club.
We are.
Wow. Now, can you ladies tell us exactly what your position is and what the club does?
Well, we are both directors. We own this together. So we decided that we come from a little bit of a background of a little bit of everything. So we decided to collaborate, put it all together, and it became this. We are like a hands-on enrichment center for kids 6 to 18 years old, and we do culinary, science, engineering, tech,
Crafts.
robotics, coding,
Arts and crafts and yoga.
Now, do kids come to you after school? Is it an after-school program?
It can be used as an after-school program to where kids that are in public school come to us later in the day. We also will be offering weekend classes and stuff, so they can come to us then, but we also cater to homeschool kids as well. So we can do morning classes for homeschool kids.
Now, you have a facility, obviously?
Yes, we have a 5,500 square foot facility, and each section is we have their own classroom, so science has its own area along with yoga, tech, so they have dedicated classrooms.
Okay, well, what is your most popular?
I would say culinary would be our most popular. Kids love to cook, and it's a lot of fun. We do everything from macaroni and cheese to Rocky Road fudge, and it's just
You got me ready.
that's good.
Another popular thing is robotics and coding, which is what we have here for a
Okay,
year.
and we have, again, Deanna and Tonya, and they have some really cool things. Can you explain what they have and what they're doing?
They have in their hands iPads which are connected to our Winter Workshop robots. They do coding, and they can code them to do anything. Right now they're doing simple maneuvers. They can code them to do anything from playing musical instruments to obstacle courses.
Antonia, can I see real quick what you're doing? Can you show me real quick on the pad what you're hitting?
And this makes you go back, and then this makes you go and then you can make it make animal noises, and then it moves.
Oh, that is very cool. It was easy to figure out.
Yeah.
Yeah. All right, we'll get on over there. I think we got a little race going on. All right,
tell
let's
them.
see. All right, Deanna, you ready? Okay, on your marks. Get set, go. Let's see who gets it. Oh, good job. And besides these are really cool because that's the first thing when I got here I saw. My eye came to these.
Definitely.
These are really cool.
They are very neat.
Now, what else do you have on the table there set out?
This is just a little fun free time stuff that we have, which would be our marble towers. They're fun for kids. You build them up in the engineering portion, and then you get to run marbles through them. They're pretty neat.
Now, again, where's your location?
Off of White Lane in Grissom.
5601 Aldring Court, Suite A1.
Great. Well, thank you so much,
Thank
ladies.
you so much. Thank you.
All right, Mike, back to you in the studio.
All right, looks like they have a lot of great things going on at that Chevron Pavilion right at the main entrance of the Kern County Fair. So if you're heading over there tonight, if you go in the main entrance right off of P Street, you'll be able to see Mary Lou, the rest of the Do the Math gang out there, and all of the different activities that Chevron is sponsoring out there this evening. So we'd like to once again say thank you to Chevron, a major sponsor here of our Do the Math program for many, many years. 636-4357 is the phone number. Don't forget, you call from San Luis Obispo. Doc Bernstein's Ice Cream Lab. You'll be getting some whatever flavor you want, I guess. But not a bad deal. Free ice cream for doing a little bit of math. Right now, we'll go back to the phones. Abraham, how are you today? Are you there, Abraham?
Yes.
And you're a student at Reagan, correct?
Yes.
As soon as you're ready, let's hear that math problem.
Okay, so my math problem is negative 3n, open parentheses, 1 minus 2n, close parentheses, plus 2, open parentheses, n plus 4, close parentheses.
Okay, did I get it all? Negative 3 parentheses 1 minus 2n plus 2 parentheses n plus 4, right?
Yes.
Okay, so now, Serena, we're back to expressions. So no equation to solve. So Abraham, what's the first thing we do?
We do negative 3n times 1.
And then we do negative 3n times
2n.
negative 2,
Negative
right?
2n.
So let's go ahead and do
Yeah.
that multiplication. Now, this is easy because what's 1 times anything?
3.
Itself, like minus
Itself. So
3n.
let's write down minus 3n, right? Minus 3n.
Yes.
And don't forget the negative in front.
Yes.
Now, what's negative 3n times negative 2n?
Positive 6n squared.
Because negative 3 times negative 2, negative times negative is positive, right? And n
Yeah.
times n, we just looked on the student from El Cajon, we know that an exponent, right? N times n is n raised to the second power. So let's write that
Yeah.
down. Plus, and we have a 6, n, have you used exponents, Serena?
Yes.
So write down n, and then raise it to the second power. Okay? All right, so there's our first set of parentheses. How about the second set? Same distributive property, right?
Yes.
What do we get? 2 times n?
Yeah, 2 times n and 2 times 4.
So plus
Plus 2n.
2n. And the easiest part of the problem is 2 times 4.
Yeah.
So what is that? Plus 8. Okay. So now we've got 1, 2, 3, 4 terms, and we've got to combine like terms, right?
Yes.
So what like terms do we have in this expression?
Negative 3n and positive 2n.
Right. That 6n squared has the same letter, it has an n in it, but it's being raised to the second power. So it's different than these two terms. And the 8 doesn't have an n at all, so it's different. So the only combining of like terms is minus 3n plus 2n. What is that?
Yes. Minus 1n.
So we can write down minus n, we don't need the 1, right? So just minus n, plus 6n squared,
Yeah.
plus 8.
Yeah.
Now, do you leave your answer like that?
Yeah.
You can, right? So that's sometimes an acceptable answer for the problem they give. But very often when they give you a problem like this with variables in different powers, very often they'll ask you to put it in order from highest power to lowest power. So very often if you look this up, say in an answer book, they'll put that 6n squared first, then the minus n, because that's n to the first, and then a plus 8 because it doesn't have a variable at all. So very often you'll see it in this last form instead of this form, just because they put the n squared before the n, before the 8. All right, and there's your answer. Thanks for the call.
Thank you.
All right, nicely done right there. 636-4357 is the phone number. We do have phone tutors available until 5:30 on Tuesdays and Wednesdays. One thing I'd like to bring to your attention are the stickers that we hand out, and these go out throughout all of Kern County. They go to every single school in Kern County. If you have not yet received these stickers in your classroom, all you have to do is give us a call, say, hey, I'm a student at this school, we haven't received those yet. We can kind of figure out, are they still in your office? Does the teacher actually have them? Have you gotten them yet? And we can pass them out if indeed we do need to send more out there. But those stickers have all of the information that you would ever possibly need to do on there. Are you nervous at all doing these problems?
At first.
At first, right? Well, because it was brand new to you, right? And you had no idea what was going on. But are you kind of getting the idea of how these expressions work?
Yes.
All right, there you go. So it's a good thing you're in there this afternoon. Get you ready for 6th grade and the end of 5th grade, okay? All right. You know what? We're going to go to the phones one more time. All right. Aiden, how are you today?
Good.
And you're a 6th grade student at what school? Aiden, what school do you go to?
River.
All right. As soon as you're ready, let's hear the math problem that you're working on.
My math problem is 7n minus 17 equals 4n plus 1.
Okay, let me make sure I got that right. You said 7n minus 17 equals
yes.
4n plus 4? So I got that equation correct? Okay? So what we're going to do is we're going to solve this equation. And remember, solving an equation means find the value for n, right?
Yes.
Okay? Which means when we're all done down here, we want n equals something at the bottom. So we've got to get all of those n's together and then get n all by itself. So Aiden, what's the first thing you're going to do?
You're going to add 17 or divide it?
Okay, so the question is, do you want to work with the variable term first or the number? You can choose.
Number.
Okay, so you said that minus 17, right?
Yes.
So we got numbers on both sides of the equation, don't we?
Yes.
But we want them all on the same side, so we have to get rid of them on one side. You said get rid of the 17?
Yes.
And how did you do that?
Add 17.
All right, so because it's being subtracted, so right below that, so we're going to go ahead and write plus 17.
And then it cancels each other out.
And then on the other side, to keep this thing balanced, right?
Yes.
We have to add a 17 over there, and we're going to add it to the 4. We're not going to add it to the 4n, are we? No. We're going to add it to the number. So just like before, I'm going to do the easy part. And you said minus 17 plus 17, that's 0, isn't it?
Yes.
Okay? And what do we get on the other side?
You add 17 to the 1.
So over here we get 7n, and over here the 4n is all by itself, and what's 4 plus 17? I'm sorry, did you say 4n plus 4 on this side?
No, 4n plus 1.
Plus 1, I'm sorry. So this is a 1. All right, so what's 17 plus 1?
18.
All right, so plus 18. All right, so we got all the numbers on one side, now we got to get the letters over here. How do we get rid of that 4n?
We subtract 4, or we divide 4 by negative 4.
Well, let's see, we know that this is a positive 4n, right? It's being added to that 18, so how do we get rid of it? What's the opposite of adding?
Subtracting.
So you were right, we're going to subtract, aren't we?
Yes.
So below that 4n, so we're going to go ahead and put a minus 4n.
So we're going to minus the 4n or just the 4?
No, the whole thing. We're going to take care of that entire term, okay? By subtracting that 4n here. But again, whatever we do to one side,
We have to do
reduce to the other.
Got to do the other. So over here, let's see a minus 4n under there. All right, so now let's combine those terms. Again, I'll do the easy part. 4n minus 4n just cancels out at 0. What do we have over here? 7n minus 4n. How many n's do we have? If we have 7 of them, we take away 4, we have?
3.
3.
So 3n.
Okay.
Equals, what's on the other side?
18.
The only thing left is 18, isn't it?
Yes.
So there's a new equation. 3n equals 18. How do you solve for n?
Can you repeat that?
So we have 3n equals 18. We want to get n by itself, don't we?
Yes.
How do you get rid of that 3?
By minusing a negative n on it.
Well, let's see. We have a 3n, right? That means 3 times n, doesn't it?
Yes.
We know that 3n has a multiplication between it. What's the opposite of multiplication?
Division.
Division. So now we're going to divide. So I'll show division by a fraction bar, right? What do we have to divide by to get rid of that 3?
3.
3. So let's divide both sides by 3. And 3 on the other side. And again, I'll do the easy part. 3 divided by 3 is
0.
well, it goes away, but it's 1, isn't it? It's just 1 n.
Yeah.
Equals, and what's 18 divided by 3?
6.
And 6. So it looks like your answer is n equals 6. What do we do with that answer? Do you have to check your work?
Yes.
So we're going to take that answer, n equals 6, and go all the way back up to the beginning. Let me do this check quickly. 7 times 6, we know that's 42, right?
Yes.
Minus 17. And here we have 4 times 6, that's 24, plus 1. Well, that's easy. 24 plus 1 is 25. What's 42 minus 17? It better be
25.
It better be 25, and it is, isn't it? So our answer checks, and n equals 6 is our answer.
All right,
Thanks for the
nicely
call.
done right there. You know what? We've got a few more minutes. Let's head back out to the Kern County Fair with Mary Lou.
We are back live at the Chevron STEM Pavilion at the Kern County Fair, and I'm here with Michael Coleman, Superintendent of Fairfax. How are you doing today?
Hello, how are you doing?
Good. Can you tell us who you brought with you today?
Oh, I'm excited. I brought here our Virginia Avenue STEM class. They spent some time. Really appreciate the Chevron allowing such a good focus on science. Fairfax School District is a real proponent of science. We have STEM classes at each of our campuses. So we're just excited to bring our kids here and share some time with you here today.
All right, let's check out what you have. All right. Hey, how you guys doing? Okay, can you tell us what you brought today? A what?
A DIY lava lamp.
And a lava lamp. And how did you do that?
First, we took water, and then we took vegetable oil, and then we added food coloring, and then we took the salt or Alka-Seltzer, and then we stuck it in, and then it goes up.
Can you turn it and show us how it works?
Sure. It's easier to break it into 4 pieces. And then you put on the top.
There you go.
And then you take the light and put it under it or through it. But it's kind of hard to see.
Wow. Oh, I see it. Very cool. Impressive. Thank you. All right, next. Ladies, what have we got here?
We're going to represent friction.
Friction. Okay, how?
Friction, first we have these plates, and you can try this, and
Okay.
you can try to rotate
Vienna, get in there.
to rotate this, and it will be a little bit hard at first, but when you put soft surface like these foam balls, they're like round and soft, and when you try to turn it, it's easier and it turns itself.
Very good. Thank you. Hi, how you guys doing?
Good.
Okay, what do you have here How does it work?
All the iron fittings gather together at the top with the magnet, and it brings the slime with it.
Wow. And did you guys make this?
Yes. We had already made it as soon as we got here.
Very cool. Gentlemen, what are you doing over here?
Right here we made a circuit to control this fan right here, this miniature fan, and when we click right here, it closes the circuit.
When we hold the button, it'll close the circuit
so they can't
makes the fan like
stop.
on.
And then when we let go, it starts powering itself.
Impressive. And lastly, look what we have. We have Casey the Bull. How you doing? Now, what are we doing here, guys?
So here we're going to do the challenge. Her and Casey have made a boat, and they're going to see which one can hold the most pennies.
All right, let's go.
The record is 188 pennies.
All right, you got about 30 seconds. Ready, set, go. Count 30 seconds for me.
One, two, you can do it. 4. Start putting them in there.
Come on! Oh, he's nice job! Nice job, you guys! Nice job. Well, you guys, this is amazing. Thank you. And we want to thank everybody who participated today at the Kern County Fair. Thank you for having us today. All right, back to you, Mike, in the studio.
All right, thanks a lot, Mary Lou, and everybody out there with the Kern County Fair. And we saw KC the Bull out there partaking in a little science activity. Well, Serena, since you did such a wonderful job this afternoon, we're going to send you home with a brand new uniform. So we'll turn this way so everybody can see that. Now, I know that your mom will be very pleased to know that you're going to wear this every day for the rest of 5th grade. Maybe not every day. How about every Tuesday and every other Wednesday? How's that? We can work out some sort of deal like that? All right. So, did you have fun?
Yes.
All right, good. I'm glad you had fun. Did you learn a little something with the expressions and equations?
Yes.
Very good, because you'll be doing those quite soon in school. What we'd like you to do is reach in there, and all the students that phoned in today are eligible to go see the Condors, and let's find out who's going. Vienna at Reagan Elementary. So congratulations to Vienna. You've got yourself 4 Condor tickets. Congratulations, and until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, California Resources Corporation, Southern California Edison, Kern Schools Federal Credit Union, Panama Buena Vista Union School District, and the San Luis Obispo County Office of Education, with additional production assistance provided by the supporters of education in Kern County and throughout the state of California.